Hey, what's up everybody? This is Ryan Clark here from JIGMOD, and I'm going to show you how to use Arduino with the JIGMOD system to control some stepper motors using an old PSX controller. I'm using a PSX Controller decoder library, and each axis of the thumbsticks provides a digital value between 0 and 255, and capturing those values in real time allows you to use a PSX controller to do basically anything you want using an Arduino. I've also used a generic stepper motor library that comes with the Arduino software package. I'm using the Arduino Mega board with the stepper motor drivers wired to some of the outputs. I also have the wireless PSX controller module connected to the PSX Controller JIGMOD. I'm powering the entire circuit using two 3AA battery JIGMODs, which are providing about 5 volts and supplying a constant 600 milliamps of current. The description contains a link to where I purchased the stepper motor kits and the wireless PSX controller, as well as the PSX controller decoder library and sample code. Now, one thing about stepper motors is that they are often energized even when they are not moving. As long as one of these LEDs is on, that means that the stepper motors are energized. The Arduino board is powered from the breadboard, so this is a great example of having your Arduino being used out in the field without being tethered to your computer. Once I've programmed the board, it runs the same program every time it is powered up, regardless of whether it is connected to a computer or not. So I've written the code to take the thumbstick y-axis values and move the motors accordingly. If I push up on the thumbsticks, the binary values increase, which satisfy if statements that make the stepper motors turn by 50 steps. On the oscilloscope we can see the output to the stepper motors, and one thing about the stepper motor library is that your entire Arduino program fully dedicates its processor to the stepper motors. So on the oscilloscope we can actually see those tiny intervals that the program takes to go back to the main program and check what the thumbstick values are. It seems quite fluid in real time, however the waveforms on the oscilloscope prove that the stepper motors are stopping about 10 to 20 times per second for the code to go back and read the PSX controller values. So overall, we've got a self-contained configuration that we could use to control a robotic arm, or drive some other machinery, or even construct a wireless robot and take it to school or wherever we want to. If you like the JIGMOD electronic circuit building system, check out my Kickstarter video in the description and find out how you can pre-order and get one of the very first JIGMOD kits out there. Thanks everybody, and I hope you liked the video. See you next time.